All right, so this is our first lecture on section 2.3, linear graphs and rates of change. So everyone should have already taken the initial knowledge check in ALEKS at this point and be ready to move on and start the objectives in 2.3 after having finished the algebra review and the algebra review quiz. Okay, so this is for those objectives in 2.3, like we said, linear graphs and rates of change. So the first thing that we have is forms of equations. So different equations we have to think about the different types of equations. So the first one we'll talk about is slope-intercept form. Slope-intercept form is y equals mx plus b. Now let's think about what each of those things mean. Again, just kind of a refresher. So we know y and x are the variables, the point that makes x, y, right? We know m is what again? Well, m is the slope, right? So remember, slope is the change in y over the change in x. Okay, so slope formula, as we can remember, is, now it doesn't matter too much if we do 2's or 1's and in what order we put points in, as long as you put kind of whatever you put first for y's have to go first for x's. So if we have y2 minus y1 over x2 minus x1. Okay, and again, you could switch it around and make it y1 minus y2 over x1 minus x2 as long as it's consistent and you have this as one point and this as one point. And you always subtract, meaning that if you had a point that had a negative value in it for x or y, right, that could turn into a positive because minus minus makes a plus, right? So, okay, then we have that one last piece, the b. b is the y-intercept, right? It makes the point 0, b. Because it's the y-intercept, that means the x value is 0, right? All intercepts, whichever one you're talking about, x or y, always has the opposite value be 0. Okay, so after slope-intercept form, we have then point-slope form. Point-slope formula is a little bit longer, but in some cases it's actually simpler and easier to use depending on what types of information you're given. So point-slope formula is y minus y1 equals m times the quantity x minus x1. Okay, so let's decipher that down again. So y and x again are the point, right? But, however, just y, not y1, and just x, not x1, are your variables for the equation. We don't replace those if we're trying to use this equation to write an equation or to solve with it, right? We leave those alone because to have an equation, we have to have a y and an x. Otherwise, it won't be this type of equation, right? It won't be a linear line. So our actual point here is x1, y1, okay? Now, notice the equation does again have these negatives. So whenever kind of the value is with the kind of variable of it, right, you always subtract the value, okay? So again, if we had like the point -1, -2, well, that would be y plus 2, right? Minus minus, and then we don't know m, and x plus 1, okay? We always change that sign. So then again, m is slope. That never changes. Okay, so those are two kind of forms of equations that we have. We have the slope-intercept and point-slope. Those are basically the two that we'll use primarily talking about lines. Okay, so then next is having an example of using these lines to evaluate. So first they want us to solve the formula for y. So the first thing we should do is notice that we want to isolate the term that has y in it, right? We want to get that term by itself. So don't just always kind of go by rote memorization, right? We want to think about what we want from an equation or a problem or whatever we're dealing with in math. What do we want from it, right? In this, we want y. So we want to get the term by itself first. So add 6x over. So we have 2y equals 6x plus 4. I wrote it that way just generally because we see the x term first and then the constant term. Think about the slope-intercept form. So now notice we have the y term by itself, so now we want y to be by itself. So that just means divide by 2. Now, however, I'm not going to divide everything by 2 because I want to take it into each term again, right? So that means I'm going to divide like this by 2 so that we can simplify and have our slope by itself and our y-intercept by itself, not as kind of a whole big fraction that's not simplified. So our last step here would be y equals 6 over 2, so 3x, plus 4 over 2, so 2. Okay, so that's our equation. Now, they want us, after solving the formula for y, they want us to then evaluate, basically find the y that goes with these x's, right? So that means, well, y equals 3 times the first one, 4, plus 2. Okay, so simplify. 3 times 4 is 12, plus 2 is 14. So then we can write these out in point or ordered pair form, meaning if we have 4, we get 14. It's a good way of kind of gathering the information because if we just say, oh, well, y equals 14. Well, when did y equal 14? What was the x value? What were the circumstances? Does y always equal 14, right? So you always want to be sure for you and for answering problems, write down kind of as much information about the thing as you can, or whatever formatting Alex software is asking for it in. Okay, so then the next problem or portion of this evaluate is saying y is equal to 3 times 0x plus 2. Okay, well, 3 times 0, anything times 0 is 0, plus 2 is 2. So again, we have a point of 0, 2. Okay, so one last time with the fraction, y equals 3 times negative 1/3 plus 2. Well, think about the 3 as really being over 1, right? So 3 over 1 times negative 1 over 3. Well, those 3's cancel, right? So really, we're left with negative 1 over 1, which that's just negative 1. Plus 2 is 1. So our third and final point is negative 1/3, 1. Okay, so we solved a formula for y, and then we evaluated and found 3 different y values from 3 different x values, and then wrote them in ordered pair form. So the next thing is kind of talking about these a little bit more, right? Now that we've kind of done a problem with it. So we already said the slope of the line is m and the y-intercept is 0b. So let's talk about it in terms of a graph, right? So if we have kind of a basic graph here of y and x, right? Remembering that this is the y-axis, this is the x-axis. If we're talking about the point 0b, so 0b is always going to be somewhere on the y-axis, right? It's the y-intercept. So this basically is a change here of b amount, right? We didn't go over any for 0x, right? We just went up by. So then the slope would say, well, okay, we have m is equal to some change in y over some change in x. Delta just means change to us. So if it's a positive slope, right, that means you go up y and over x. So y and x to some point here, and we can keep doing that, right? And get another point here, and then we have a nice line, sort of a line. Then technically we could also then sometimes have a negative slope. If our slope is negative, right, that means you only go negative in one direction, okay? You pick one, basically. Either go down y or go left x, okay? Because negative lines are like this, right? So we go down y some, and then to the right still for x, okay? Or you could go up still for y, but to the left for x, right? Both of these points still make that negative style line. Now again in kind of the positive direction, just like we went to the kind of up y and to the right x, we could go down y and to the left x. And that would still kind of continue on that path, okay? So those are kind of the connections that this line could have to a graph with positive and negative slopes and y-intercepts. Okay, so the next thing we'll talk about in this section is parallel and perpendicular lines. So first, let's think about the different types of intersections of lines we could have. Well, the first one is they intersect, but there's nothing special about the intersections, right? They just intersect. Then they intersect in a specific way at a right angle, meaning, well, this is, so remember first, the first one is nothing special. Okay, then that second one we said was at a specific angle, so we call that perpendicular. We'll talk about the slopes of these in just a second. Then the third kind of type of intersection is if they don't intersect at all. That means they cannot change, right, how far away or close together they are to each other, right? Because otherwise it's a line, so they'd either have to intersect somewhere or they don't intersect at all. Okay, so this one is parallel. When we have these two kind of special ones, the perpendicular and parallel, we want to know something about their slopes. So parallel slopes means, well, let's think about those lines. They're next to each other and they don't change how far away, they don't get closer, they don't get further away. That means they're going up and over at the same rate, meaning the slope of line 1 is the slope of line 2, meaning they have the same slopes. All right? So then perpendicular, well, we kind of maybe have an idea for that. They're not just, we can't say opposite because that means different things in math. So what we say is we notice that this one has a positive slope and this one has a negative slope. However, it's not just positive, negative at any old kind of rate. That's this one here, right? We want specific kind of connection between the two, so we do the negative reciprocal rate. So the first slope is equal to the negative reciprocal of the second one. Okay, so now let's do an example with these. If we want to find this equation having a parallel line to it going through this specific point here, right? So first we should find what, right? Let's go back and think about what it means to us to be parallel. Parallel means same slopes. So that means we want to find the slope of this line. So then we can write out an equation. So let's solve this for y because that's the easiest way of telling the slope. So remember, we want to isolate the y term and then isolate y. So 3y will be equal to negative 2x plus 6 divided by 3. Again, doing it individually term by term. So y is equal to negative 2/3 x plus 2. Now, the only thing we care about here is the slope and this point, okay? That's the only thing we need to write out a parallel line. So, parallel lines, we can use two different equations that we've had from the very beginning, right? We have point slope and slope intercept. Now, let's think about what we have. Do we have an intercept? No, because this does not have a 0x. So we have a point and a slope. We have an equation that's called that. So let's use that one. It's a little easier and straightforward to plug into. So remember, that's y minus y1 is equal to m times x minus x1. Now, if you're more comfortable plugging into the slope-intercept form and finding b, then feel free, go ahead and do it that way. I prefer doing it this way because that's the information we have, and I always found it a little easier. So we have y, and then the point has a negative 1 value, so plus 1 is equal to, the slope is negative 2/3 x minus negative 6 for the x value, so plus 6. That's our parallel line. Now be careful with Alex. They could just say, okay, answer box, what's the equation? Or they could say y equals answer box. So that means you have to get it in y equals format. That does not mean you need it in slope-intercept form. That just means it has to be y equals, right? Or they could ask specifically for the slope-intercept format. So just be careful that you're giving the correct format. That's not something that I can fix and go in and give you credit for in homework. So that just means you'll have to do the problem again possibly. So just always be careful of those formatting issues. Tests and quizzes, things like that, I can give points there. All right, so then on this one, we have found the parallel line. Now, let's do one other thing. Let's find the perpendicular as well. We've already done most of the work. Remember, perpendicular just means negative reciprocal slope. So we already know the slope, it's negative 2/3. We know the point, it's negative 6, negative 1 still. We can still go ahead right away and write this line. So that means the line will be y still plus 1. Now, negative reciprocal. Let's think about what a negative reciprocal is. Negative just means, oops, my plus didn't happen there. Negative just means change the sign. Reciprocal means flip it. Right? So if it's already a fraction, that makes it super simple. It becomes plus, you don't need to write the plus, but I'm just writing it to be explicit here. 2/3 reciprocal is 3/2. So then x still plus 6. That's the perpendicular line. Again, watch the format, but that's all they want. That's all it is. So if you already found the slope, then you've actually done most of the work already. So it's not too bad at that point. Okay, so next, let's look at one last example, kind of a word problem approach to putting information about a line. So 5 years after purchase, the auditor of a newspaper company estimates the value of their printing press is $60,000. Okay, so we have kind of pieces of information there, but let's continue reading. 8 years after its purchase, the value of the press had depreciated to $42,000. Find the linear equation that models this depreciation and discuss the slope and y-intercept in context. Okay, so they want us to write a linear equation that models this depreciation. Okay, so they're telling us that we have 5 years. We only have the printing press worth $60,000, only in terms of how much they're actually worth, right? So generally, we always put time in the x variable. So we're going to have it as time and then money, okay? So then we have 5 years and 60,000. Now notice I didn't put a comma there because it gets a little confusing when you have commas in your numbers, right? Within an ordered pair with a comma already there in the format. So a lot of times we don't use commas necessarily within numbers in problems. Just kind of when you're writing about them, it looks a little nicer and it's easier to read them. But in this format, just be careful with your commas, that they actually mean something to the answer. So that's our first point. And then the second one, we have 8 years after its purchase, we depreciated down to 42,000. So 8 years, 42,000. Well, so now we have 2 points. They want us to find a linear equation. Well, to find and write out any linear equation, we need to either have 2 points or a point and a slope. Well, we have one of those options, right? So to write a line, we need to know slope though. We can find slope. We have 2 points, right? Just using that y2 minus y1 over x2 minus x1. So again, it does not matter which one you make to be 2 and 1. So let's calculate the slope. I'm going to put the 60,000 on top. So 60,000, first I meant not on top, minus 42,000 over then, since we put 60,000 first, we have to put 5 first. Minus then 8. So y minus y over x minus x. All right, 60 minus 42. Thousands stay there, but we can just think about 60 minus 42. So 60 minus 42 is 18. So it's still 18,000 though. Okay, then we have 5 minus 8, so that's 3. We can simplify this though. 18 is divisible by 3, so 18 over 3 would be 6, so 6,000 still. I always kind of do piecemeal math like that when I don't have a calculator. So we know our slope, it's 6,000. We know we have a point, right? We have 2 points technically. Now again, I'm going to write it out in the point slope formula. So we have y minus, I'm going to go ahead and use that first point. So 60,000 is equal to 6,000 x minus 5. So they do say to discuss the slope and y-intercept, meaning we probably want to put it in slope-intercept form. All right, so that means y minus 60,000 is equal to 6,000 x minus, now 5 times 6,000, well 5 times 6 is 30, so that means this is 30,000. So then we'll add the 60,000 over, and I didn't quite leave myself enough room, but I will put it here on the bottom. We get y is equal to 6,000 x plus, because minus 30,000 plus 60,000 is plus 30,000. Now let's think about what these things mean to us. So it says that we're talking about a printing press, right? And it's depreciating. Now, did we forget something possibly? Because I just caught something that I didn't write out. 5 minus 8 is totally negative 3, right? So we'll kind of emphasize that with that red line. So this is a negative slope, meaning this is negative 6,000. Mistakes happen, just be sure to catch them. This is why we're thinking about it in context, right? This is depreciating, meaning this should have a negative slope. Okay, so then negative 6,000 times negative 5 would be positive 30,000. So we just completely changed our formula by that one little thing that we didn't do. So this is no longer 30,000. This is now plus 30,000 plus 60,000 is 90,000. Meaning, well, what do y-intercepts really mean? Let's think about a graph for a second. If we have this kind of graphed out, plus 90,000, well, that means we start way up here at 90,000, right? And then every one we go over, every 1x, well, what is 1x? 1x is a year, right? Because x is time in years. So every 1 year that we have the printing press, it goes down in negative $6,000 in value, meaning this will kind of drop down, right, like this, more or less, so that at some point the printing press isn't worth anything. Okay, so that means the value of the printing press started at $90,000. Then every year it loses $6,000 in value. So we can interpret these things based on the units of x and y that we kind of wrote out here at the very beginning of the problem and talk about what they mean within those things. Okay? So this is the end of this section. We talked about lines and formats, how to do things with them, parallel, perpendicular, and then also kind of word problem aspects of it. Okay,